Hey guys, today we're going to be taking a look at the top 10 hardest math problems that have come up on the SAT. These are from many years, 7-8 years ago, all the way up to 2024. So we're going to be taking a look at how to solve them in great detail with a lot of good explanations. So without further ado, let's get started. Okay, so we can see that our first problem is if 3x minus y equals 12, what is the value of 8 to the power of x over 2 to the power of y? As usual, you can pause this video and give this problem a go, but for right now, I'm just going to tell you the solution and walk step by step through it. So let's look at this 8 to the power of x over 2 to the power of y. So we see 8 to the power of x to the power of y. The top part can be rewritten as this. So 8 to the power of x over 2 to the power of y can be rewritten as 2 to the power of 3 to the power of x over 2 to the power of y. Why can we write it this way? Well, 8 is nothing but 2 to the power of 3. And the reason I wrote it this way is that we see we have a 2 in the numerator and a 2 in the denominator as a base. So now we have 2 as a base. We can rewrite the top part as 2 to the power of 3x. So we have 2 to the power of y down below. Next, this can be further simplified into 3x minus y. Now, we see a little correlation. We see 3x minus y over here, and we see, what did they give us? Oh, they gave us 3x minus y. So we can simply just replace the value of 3x minus y with the value they gave, which was 12 in this case. We're going to replace 3x minus y with 12, which is what they gave, which is 2 to the power of 12. And that seems to be our final answer. It's just A, 2 to the power of 12. Now let's take a look at our second problem. Points A and B lie on a circle with radius 1 and arc AB has a length of pi over 3. What fraction of the circumference of the circle is the length of arc AB? So let's first visualize this. We know when it's talking about arc, it's going to be talking about circle, so let's just draw a rough circle. That's our circle with a radius of 1 because that is what the question says. So we have a circle with the radius of 1. And there are 2 points that lie on the circle, A and B. So I'm just going to assume A is over here and let's say B is over here. So this, let me do that in a different color. This is arc AB. And it says that arc AB has a length of pi over 3. So this length is pi over 3. Now the question, the actual question, what it's asking is that what fraction of the circumference is the length of arc AB. So in other words, it's saying length of arc AB over the entire circumference. And how do I know this? Well, it's just saying what fraction of this is this whole thing. So obviously this is going to be less than 1, right? Because if it's pi over 3, if AB is part of that circle, then obviously that length of AB over the entire circumference is going to be less than 1, hence a fraction. So how do we go about solving this? Well, in order to solve this, we already know the length of arc AB, right? They gave us that is pi over 3. But now we need to find the entire circumference. What's the circumference of a circle with radius 1? Well, if we recall the circumference formula, that is C equals 2 pi r. We already know what r is, which is just 1. So therefore, C is equal to 2 pi. Now we have the circumference, and all we have to do is replace it in this little formula we have. So length of arc AB, we got that was pi over 3, over the entire circumference, which is 2 pi. Dividing this, we get pi over 6 pi, which is pi and pi cancel out, and you are left with 1/6. Now on to problem number 3. In triangle ABC, the measure of angle B is 90 degrees. BC is equal to 16 and AC is equal to 20. Triangle DEF is similar to triangle ABC, where vertices DE and F correspond to vertices A, B, and C respectively. And each side of triangle DEF is 1/3 the length of the corresponding side of triangle ABC. What is the value of sine F? So that was a lot of information, but whenever we're dealing with geometry problems, I always like to draw, usually in this case, a triangle. So let's start with that. We see that the measure of angle B is 90 degrees, so obviously we need to draw a right triangle. So let's do that right here. We have our right triangle. And this is going to be B because over here it says angle B is 90 degrees. And now we could just label it as A, B, C. Here it says BC is 16 meaning like 16 centimeters, 16 feet, it doesn't really matter, just 16 units. Same with AC. AC is 20. All right, so we have ABC, BC is 16, and AC is 20. So that is the first line fulfilled. Now it is triangle DEF is similar to triangle ABC, where vertices D, E, and F correspond to vertices A, B, C. Now, triangle DEF is a separate triangle, but it still shares similar properties with this triangle. Similar properties meaning that all the angles are still the same. So let us draw this triangle DEF so it corresponds to ABC. This means that triangle ABC and triangle DEF, so A will correspond to the angle D, B will correspond to the angle E, and C will correspond to the angle F. Now, let us draw that. So we have another triangle over here, just a different size. So we have A corresponds to D, so D will be here. E corresponds to B, E will be here. And F corresponds to C, so F will be here. And once again, this is a 90-degree angle because E corresponds to angle B. Now that we have ABC and DEF, let's move on to the next line, respectively. And each side of triangle DEF is 1/3 the length of the corresponding side triangle of ABC. Okay, well that worked out perfectly because if we know that DEF, each side in DEF is 1/3 the length of each side in ABC, then that means that triangle DEF will be relatively smaller than triangle ABC because each side is 1/3 that of ABC. Now it's asking what is the value of sine F. So sine F, so the angle F is over here. We know sine of, well, anything is opposite over hypotenuse. Opposite over hypotenuse. So now we don't know the opposite and we don't know the hypotenuse, but let's see if we can find it out. This corresponds to this, so we can write 20 over 3. So what we could do is apply that Pythagorean theorem. So over here, we can do 400 because we do 20 squared minus 16 squared, which is 256. And currently, I'm finding this side. I'm currently finding side AB. And this is equal to 1, which is 12. So side AB is 12 units. Now that we know side AB is 12 units, using this 1/3, we could say that side DE is 4 units. Now we could say that sine theta, in this case sine of F, is 4 over 20 over 3. In this case, sine F is equal to 4 times 3 over 20. Canceling that out, we get sine F is equal to 3/5. Now on to the next problem. In the figure, arc SBT is 1/4 of a circle with center R and radius 6. If length plus width of rectangle ABCR, so ABCR, is 8, then the perimeter of the shaded region is what? So once again, this is a geometry question, so they have drawn the figure for us already. Now let's see what we can grab out of this figure. So we can see that's asking for the perimeter of the shaded region. Well, what's the perimeter of the shaded region? Well, it's nothing but SA, which is, let me do a different color, SA plus AC plus AC plus CT plus CT, and finally plus arc TBS, arc TBS, and that is the perimeter. So now this is essentially what the perimeter is without numbers. Just looking at the figure, this is what we got. Now let us see how we can incorporate some numbers into this. So first off, I see that it says arc TBC, and in the problem it also says that the radius is 6. So if we know the radius and we know that it is 1/4 of a full circle, then we can find out the length of arc TBC. How can we find that out? So arc TBC, let's say TBS, my bad, TBS. this is actually, first let's calculate the circumference of the entire circle. So calculating the circumference of the entire circle, we know circumference is 2 pi r, and we know r is 6, as says over here. So r is 6, so we get 12 pi. The circumference of the full circle is 12 pi. But we know that this is not a full circle, it's just 1/4 of a circle. It says right there. So what do? We just divide the entire circumference by 4. So 12 divided by 4, that's 3 pi. So therefore, TBS is 3 pi. So this is 3 pi. Now that we are done with that, we found TBS. Let's see if we can find SA, AC, and CT. So SA is this right over here. AC is this right over here, and CT is this right over here. Unfortunately, they did not give us the measurements of either of those. They did not give us the measurements of SA, AC, and CT. So we can't rely on just substituting whatever we have in the problem in for this perimeter. So what do we do next? Well, let's actually kind of make SA into a form where we know the numbers for that form. Now that's a lot to say, but let's see what we're going to do. So looking at the figure, very basic, we know SA is nothing but SR minus AR. SA over here is nothing but SR minus AR. That is just SA. Okay, now let me clear this a little bit more. Alright, so this is SA. Now, let's see AC. AC is this diagonal over here. And we know that the diagonals of a rectangle are always equal to each other. So basically, AC is also the same thing as BR. So let's say BR, and you will see why in a moment in the next step. So now we have AC written as BR. Now let's see what we could do with CT plus CT. Also, at the end, we have a plus 3 pi. I'm just going to move that over here. So that's plus 3 pi because that is the length of our TBS. Now for CT. CT is over here. Well, CT is nothing but RT minus RC. CT is nothing but RT minus RC. Now, let's see what we can find after this. So we know that SR is what? SR over here, we see that is 6 units, as seen over here. That is 6 units, so 6 minus AR. We don't know AR just yet, so let's hold off that for now. AR plus BR. BR is this, and it already says the radius is 6, and BR, well, if you look at the entire 1/4 of the circle, we see that BR is the radius. So radius is 6, BR is 6 units. Plus RT. RT is once again the radius of that 1/4 of the circle, so RT is also 6. Minus RC. Minus RC. We don't know what RC is yet, so let's just write RC as it is, and then we have 3 pi because of that TBS arc. Simplifying this, we have 6, which is 18, minus AR plus RC. I just took the minus out of AR and RC, plus 3 pi. Now we have AR plus RC. And actually, in the question, they said another hint, or so to speak, a hint. It says if the length plus the width, of rectangle ABCR, so ABCR is 8. So that's basically saying AR plus RC is 8. Length plus width is equal to 8. So therefore, we could just replace 18 minus 8 plus 3 pi. Simplifying this, we are left with 10 plus 3 pi. And that is the perimeter of SA plus AC plus CT plus arc TBS. So our final answer is, let's see, 10 plus 3 pi. Our final answer is B. Alright, so now for the next problem, we are given an expression 8 minus I over 3 minus 2I. If the expression above is written in the form of A plus BI, where A and B are real numbers, what is the value of A? And they gave us a little note. I is equal to root of minus 1, aka that imaginary number we've learned about. So once again, feel free to give this problem a go, but for right now, I'm just going to go over the solution. So we see we have this expression 8 minus I over 3 minus 2I, and they're asking us to write it in this form. So first thing I see off the get-go that a plus bi doesn't really have a denominator, so we need to get rid of this 3 plus 2I somehow. And the trick to solving most of these imaginary number problems or problems relating with imaginary numbers always has something to do with multiplication of some sort, because we know that if you multiply I times I, you get -1, I times I times I times I, aka I to the power 4, you get 1. And those are fairly simple numbers to work with. And there's also another concept when we're talking about imaginary numbers, and that is multiplying by the conjugate. So for example, if we have 3 plus 4I, for example, its conjugate, so its conjugate is going to be nothing but 3 minus 4I. So this sign just changes to that minus. Similarly, if we had an imaginary number, let's say 7 minus 6I, and we want to find the conjugate, well, its conjugate would just be 7 plus 6I. Once again, we just reverse that addition or subtraction sign in between the real part, which is this part right over here, and the imaginary part, which is this part right over here. So conjugates are really going to help us solving this problem. But how do we apply conjugates to actually find an expression in the form of a plus bi? Well, let's rewrite the question. So we have a minus I over 3 minus 2I. And over here, we're going to apply that concept of multiplying by the conjugate. And we know that if we multiply an imaginary number by its conjugate, you're going to get an actual number, an actual real number. So let us take an example once again. Let's say we have 4 minus 2I, and we multiply that by its conjugate. So let's say that the conjugate will be 4 plus 2I. Let's simplify that. 4 times 4 is 16. 4 plus 4 times 2I is going to be 8I. Minus 2I times 4 is going to be minus 8I. So eventually those are going to cancel out. Then we have minus 2I times 2I, which is minus 4I squared. These two middle terms, they cancel out. We're left with 16 minus 4I squared. Over here, they gave us I is equal to root -1. And we know that we could rewrite this as 4 root -1 squared. Root -1 squared is just going to be -1. 16 plus 4 equals 20. So 20 is an actual whole number. It's a real number. Usually you might not get these whole numbers. You're probably just going to get a fraction or a whole number, but in essence, the I will disappear if you multiply a number by its conjugate. So we could do that in this problem right over here. So once again, let's rewrite the problem. A minus I, a minus 3 minus 2I. And let's multiply the bottom part by its conjugate. Why are we multiplying the bottom part by its conjugate and not the top part? Well, because over here we see that there is no denominator. So that means if we have a whole number as a denominator in the bottom, we could split it between the real part and the middle and the imaginary part. Let me show you. So for now, let us just multiply by the conjugate. So multiplying both the top and bottom by 3 plus 2I, because that is the conjugate of 3 minus 2I. 3 plus 2I. Let us simplify that. 8 times 3 is 24. 8 times 2I is 16I. Minus I times 3 is minus 3I. And then minus I times 2I is minus 2I squared. Over 3 times 3 is 9. 3 times 2I is 6I. Minus 2I times 3 is minus 6I. Minus 2I times 2I is minus 4I squared. Now let's simplify the top first. We have 24 plus 16I minus 13I, that is just 13I. And minus 2I squared. Let's simplify the bottom. The middle two terms get canceled out. 9 minus 4I squared. Simplifying this even further, the top part let it remain 24 plus 13I, but we know that I squared is -1, so -1 times that -2 is +2. Over 9, we know I squared is once again -1, -1 times -4 is +4. So simplifying the top again, we get 24 plus 2, which is 26, plus 3i, over 9 plus 4, which is 13. And now we have a denominator, but over here they're saying that this should not have a denominator. Well, that's no problem. We can rewrite this as 26 over 13, 26 over 13 plus 3 over 13i. 26 over 13 is just 2. And, this is 13. And 3 over 13i, we can't simplify that, so we're just going to write 3 over 13i. Asked us, what is the value of a? What is the value of a? Well, we know that this is a and this is b, if we look at this part right over here. So we could say that a is equal to 2. All right, on to our next problem. In the xy plane, the point P, R lies on the line with the equation y equals x plus b, where b is a constant. The point with the coordinates 2p, 5r lies on the line with the equation y equals 2x plus b. If p is not equal to 0, what is the value of r over p? And once again, feel free to give this problem a go by pausing the video, but for right now, I'm just going to go over the solution. So let us first, we have a word problem in front of us right now, and whenever we have a word problem, I like to separate it into two parts. So two parts that I can separate this into is this first part right over here, where it gives us a point and then the equation of the line. And then the second part over here, where it gives us another point and another equation of another line. And they're asking us to find r over p. But first, let's take a look at the first part of the whole question. In the xy plane, the point P, R lies on the line with the equation y equals x plus b. So we know that we have a line and we have a point, let's say P, R as stated in the problem, and this line is y equals x plus b. And we know that if a point lies on a line, it means that point satisfies that equation, meaning that the left-hand side and the right-hand side are equal to each other when you replace the values of x and y. So that being said, we can easily say that r equals p plus b because I just replaced x in for p and y in for r. So that is our first equation. Now moving on to the second part of the problem, we see somewhat of a same correlation. Coordinates 2p, 5r lies on the line with the equation y equals 2x plus b. Once again, we have another line. Let's say that's our line. Y equals 2x plus b, and we have a point 2p, 5r. If 2p, 5r lies on y equals 2x plus b, that means the left-hand side and the right-hand side have to be equal, hence satisfying the equation. So we can replace x for 2p and y for 5r. So replacing y for 5r, x for 2p, that gives us 4p because we have to multiply it by that 2 plus b. So that is our second equation. All right, now we have to find r over p. Now, what I've seen a lot of people do is that instead of finding r over p, they find the value of r separately and the value of p separately, and then they do r over p to get the actual value, which is perfectly fine, but in this case, we can't do that because we have two equations, but we have three variables. You can only find the value of each variable when you have three equations and three variables, or two equations, or two variables. We can't do it with three variables, two equations. So as a result, what can we do now? Well, instead of finding the actual values of r and p, what we could do is simply find r over p equals something. Something is going to be whole numbers, real numbers, constants. So instead of finding r and p separately, let's just find r over p collectively. And how do we do that? Well, we see that b is a constant, meaning that the value of b in the first equation and the value of b in the second equation is going to be the exact same. So we can find the value of b from the first equation, which is b equals r minus p. I just subtracted p from both sides. Next, we can replace this into our second equation. So we have 5r plus 4p, 5r equals 4p, 5r equals 4p, plus r minus p, because I just replaced the value of b and for b in the second equation. We have 5r equals 4p plus r minus p. Simplifying the right side, we have 3p plus r. And subtracting r from both sides, we get 5r minus r, which is 4r, equals 3p. Now, they're asking us r over p. Well, we are in a lucky situation. We have 4r equals 3p. Divide both sides by p. So we have 4r over p equals 3, because p over p is just 1. Now, let's divide both sides by 4 to get that r over p by itself on one side. Dividing both sides by 4, we get r over p equals 3 over 4. And that is option B. All right, so going on to our next problem, the function p of t equals 260 times 1.04 to the power of 6 over 4t models a population in thousands of a certain city t years after 2003. According to the model, the population is predicted to increase 4% every n months. What is the value of n? So once again, I'm going to walk through the solution. What catches my eye is that the population is predicted to increase 4% every n months, and I can see that within the equation they gave me. That is symbolized by 1.04. So this increase by 4% basically means 1.04. And it says every n months. So many of you may think this is a very complicated problem, but there is no more than 2 steps to actually solve for the value of n in this problem. So what is the first step, you might ask? Well, the first step is to realize that after n months are completed, then the population will increase by 4%. So we know that 260 is the current population, right? And after n months, we don't know how many months that is. After n months, the population would be 4%, would increase by 4%. So that would just be 1.04. And then we would get the new population. So this is basically year 0. This is basically after year 0, year 1. So we have p equals 260 times 1.04. Notice that there is no exponent. There is an exponent, but that is just 1. So that means after n months, not only does the population increase by 1, but for the first time, the exponent should actually be equal to 1. So, since the exponent should be equal to 1, then only will the population increase by 1.04 for the first time. We already know the exponent is 6 over 4t, so we have 6 over 4t is equal to 1. We have 6/4 t, multiply both sides by 4, divide both sides by 6. You are left with t equals 4 over 6, aka t is equal to 2/3. But once again, we have to say this in months. T over here is in years. We can see that it says t year, so we have to change that to months. We know that there are 12 months in 1 year, and that means 2/3 of a year will correspond to 8 months. So therefore, our answer is 8 months. Alright, so now on to our next problem. The expression 4x squared plus bx minus 45, where b is a constant, can be rewritten as hx plus k times x plus j, where h, k, and j are integer constants. Which of the following must be an integer? So the following are b over h, b over k, 45 over h, 45 over k. So they're asking which of these options has to be a integer. And just keep in mind, h, k, and j, they're also all integers. But once again, if integer divided by integer doesn't always give you an integer, so there's that. So once again, feel free to give this problem a go. Right now, we're going to go over the solution. So they gave us 2 pieces of information. They gave us the actual expression, 4x squared plus bx minus 45, and they're saying that it can be rewritten as this. And they're saying which of the following must be an integer. So let us first focus on just this part. Let us rewrite this equation they gave us into this form. So in order to do that, we have to first expand this right over here. So we have hx plus kx plus j. That is equal to hx squared plus hjx plus kx plus kj. Alright, now I want to group some of these terms together. So I'm going to group the middle terms together, aka I'm going to take the x out of the middle 2 terms. So that's basically saying hj plus k x plus kj. This is equal to the same left-hand side. And looking at our equation, which is 4x squared plus bx minus 45, we can see a correlation between this equation right over here and this equation right over here. We know that the coefficient, over here attached to that x squared is h. We know that the coefficient over here attached to x squared is 4. Therefore, h is equal to 4. We know that over here, the coefficient attached to x is hj plus k. And we know that in the original equation, the coefficient attached to x is b. Therefore, hj plus k equals b. And finally, we know that kj is just simply a constant, no x attached in this expression over here. And we know that minus 45 is also a constant with no x attached. Therefore, kj is equal to minus 45. So now we have all of these relations, and now we have to analyze these relations to understand what divided by what can give us a constant, which is can give us an integer, which is what the question is asking. So we know h is equal to 4, okay? We know hj plus k is equal to b. But one thing I want to draw your attention to is this last one, kj equals minus 45. In the question, they say h, k, and j are integer constants. So k has to be integer constant, j has to be integer constants. You multiply two integer constants together, you're always going to get an integer, negative 45. And you can only get negative 45 only when both k and j are factors of negative 45. So k and j are both factors of negative 45. aka they're kind of both factors of 45, except one is going to have a minus, the other is going to be positive. So k and j are both factors of negative 45. This is all the information we need. K and j are both factors of negative 45. Going over here, let's take a look at the options. We have b over h. Is that a constant? Well, we can't really say for sure because first off, we don't know the value of b. We know the value of h, but we can't be so for sure. Next, we have b over k. This one, we also don't know. We don't know the value of b and the value of k. All we know is that it's a factor of 45. Next, we have 45 over h. Well, we already know the value of h. 45 divided by h, aka 45 divided by 4. That's not an integer value. Which leaves us with our last one, 45 over k. 45 over k, that is the correct answer. Why? Because we know k is a factor of 45. And if you do 45 divided by a factor of 45, you are always going to get an integer value. And that's only true because, once again, they specified h, k, and j are integer constants. So therefore, if you do 45 divided by a factor of 45, and we know this factor of 45 is an integer because k is an integer, therefore, it's going to return an integer. Therefore, D is our correct answer. All right, next question. A sample of oak has a density of 807 kilograms per cubic meter. The sample is in the shape of a cube where each edge has a length of 0.90 meters. To the nearest whole number, what is the mass in kilograms of the sample? So we know it's talking about density, right? And if you recall, the formula for density is mass over volume, or you could shorten it and say m over v. That seems to knock out half our battle. So we know the density is what? 807 kilograms per cubic meter is equal to mass. Well, that's what we're supposed to find out. Mass in kilograms over volume. And we know the volume is not 0.9 meters. The volume is actually 0.9 to the power of 3 because they say where each edge of the cube has a side length of 0.9 meters. So this is 0.9, this is 0.9, this is 0.9, hence the volume is going to be 0.9 cubed. So this is 0.9 cubed. Solving this, we have 807, just getting rid of the units on the left side. 0.9 cubed is going to be 0.729. Now just cross multiplying, we get 508, and remember the units, even though we're not supposed to write units, but it's good to write the units. Well, we're talking about mass, so the units are going to be kilograms. So the mass is 508 kilograms. All right, so now for our last problem, which quadratic equation has no real solutions? So whenever I see no real solutions, I automatically think it has to do something with the discriminant. For those of you who don't know what a discriminant is, if you have an expression, a quadratic expression in the form of ax squared plus bx plus c equals 0, then the discriminant, we're going to denote it as a capital D, is equal to b squared minus 4ac. Now there are 3 scenarios that D can be equal to, greater than, or less than. You'll see what I mean in a second. And each one of those scenarios represents what type of solution that equation will give you. For example, if D is greater than 0, then that means the original equation, aka this, will give you 2 real number solutions. If D is equal to 0, that means the original equation over here will give you 1 real solution. And finally, if D is less than 0, it means that equation, it doesn't have any real solutions. So 0 real solutions. And now we can kind of see a pattern. We know this last scenario is what we need because 0 real solutions here, 0 real solutions over here. So once again, D is less than 0. D is equal to b squared minus 4ac is less than 0. Now we just have to see which of these equations discriminant is less than 0. And that will be our answer. So I'm just going to erase the right-hand side for a second. So right now we know that b squared minus 4ac has to be less than 0, excuse me. So let's say this is the first one, second, third, fourth. All right, so we have to find b, a, and c from the first one. Remember, the overall form of the equation will be ax squared plus bx plus c equals 0. A in the first case is 1, B is 14, and C is negative 49. Now, in these cases, you don't actually have to solve for the discriminant. That is going to take up a lot of time, and even if you have a calculator in the test, it's not efficient in any way. You just need to know the sign. If it's positive, if you know you're going to get a positive number, then okay, that's not our answer. If you know you're going to get a negative number, okay, then you know that's our answer. You don't need a calculator to see if our overall answer will be positive or negative. Let's see what I mean. So we have b squared minus 4ac. B squared is 14 squared. Well, that's obviously positive. And then we have minus 4a is 1. And then c is negative 49. Okay, so this is positive for sure. And this is also positive for sure because that minus and minus make a positive. Positive plus positive is positive. So we know that the first one is not our answer because we want a discriminant less than 0. So the first one is not our answer. Let's go on to the second one. A once again is 1, B is negative 14, C is 49. All right, so B squared is what? Negative 14 squared, which is once again positive, minus 4 times 1 times 49. So in this case, you actually do have to solve for the discriminant. Because in this case, you have positive and then minus something. And while you could get a positive number or a negative number, you could also get exactly 0. Both 14 squared and the minus 4 times 1 times 49 could balance each other out and bring you 0. So over here, you do have to solve for that discriminant. So we know 14 squared is 196. And you also have a calculator with you, so it shouldn't be too hard. We know 49 times 4 is also 196. 196 minus 196 is 0. So this is definitely not our answer because we need discriminant less than 0. So we know B is not our answer. Let's go on to C. A is equal to 5, B is equal to negative 14, and C is equal to negative 49. All right. B squared is negative 14 squared minus 4 times 5 times negative 49. Over here, once again, you don't have to solve. We know this is always positive. Minus times minus is always positive. Positive plus positive is always positive. It's never going to be negative. So this is not our answer, and process of elimination, we get D as our answer. But let's actually prove that. So D, same thing, you find A, B, and C. We see A is 5, B is negative 14, and C is 49. So we have negative 14 squared minus 4 times 5 times 49. We know this is 96. We know this is, 20 times 49, and that is definitely greater than 196. And 196 minus a bigger number than 196 is obviously going to be less than 0. So therefore, D is the equation which has no real solutions. Alright, so hopefully you were able to solve most of those questions without my help. If you needed my help, that is totally okay. These questions were the top 10 hardest questions on the SAT for a reason. So I will see you guys in the next video, and until then, stay tuned to Mathmania.